Hi class, today we're going to learn how to convert. First, let's talk about why we're converting. Physics uses the metric system. So in the United States, we're used to using feet, pounds, and inches. But in physics, we're going to be using meters, we're going to be using kilograms, and we're going to be using meters per second instead of miles per hour. The other reason is to check your answers. So there could be a lot of times at the end of a problem where you solve for a car that's traveling 400 meters per second, and you realize that that car is going about 800 or 900 miles per hour, and you can realize that maybe you made a mistake in the problem. So it's possible to check your answers by converting. There are some very typical conversions that we're going to do. You're going to have meters to feet. You're going to have pounds to something called a Newton. You're going to have, instead of miles per hour, we're going to have to use meters per second. We're going to have to go from kilograms to pounds. We're going to have meters and centimeters. So there are some very typical conversions, and these 5 that you see at the bottom of the screen here are the ones that you're going to be using a lot. To learn how to convert, let's just go ahead and start solving some of these problems. We like to use the proportion method. I know there's other ways of converting, but I'm going to show you the way that we prefer here at Hinsdale South. In every problem, you're going to be given some sort of a value. So in this problem right here, we are given 4 meters, and we want to know how many feet are in those 4 meters. Now, every single problem, you're going to be given a conversion factor. So in this case, 1 meter is equal to 3.28 feet. So that's just something that you are going to be given all the time. You're never going to have to memorize these conversions. So let's go ahead and I'll show you how to solve these problems. First thing you do is whatever you are given, you put on the top left in the numerator here. So 4 meters is equivalent to some unknown amount, which I'm going to put as an x. X amount of feet. Now we do have the conversion factor, and we know that 1 meter is the same as 3.28 feet. Now it's really important that I have meters in the numerator on the left and meters in the numerator on the right. You have to have that. You can't just put meters in the numerator and on the other side put feet in the numerator. You have to make sure it is consistent. Meters and meters in the numerator, feet and feet in the denominator. And now it's like math class. We've got 1 meter is the same as 3.28 feet, and we want to know if you have 4 meters, how many feet is that? So we can solve this just like a problem in your math class. And when you have 2 fractions set equal to each other with one unknown, we can use cross multiplication. So I can multiply these 2 values and set them equal to those 2 values, and we can ignore the units. So we can do 4 times 3.28, and that is going to equal 1 times x. And this actually works out really easy because 1 times x is just x, and we can just do x equals 4 times 3.28. So x, our unknown amount of feet, is going to equal 13.12 feet. And we are done. Moving along. Next one. 20 pounds to kilograms. All right, so like I said before, I'm going to go ahead and put 20. I'll put LBS for pounds. That's a common abbreviation. I don't know how many kilograms that is, but I do know from my conversion factor over here that I'm going to put 2.2 pounds up on top, and I have to put kilograms, 1 kilogram, on the bottom. Remember, that's really important that you have pounds in both numerators and you have kilograms in both denominators. And again, I am going to go ahead and cross multiply. So 20 times 1 equals 2.2 times x. Now in this case, I'm going to have to divide both sides by 2.2. And in this case, x is going to equal 9.09. In this case, we are looking for kilograms. I usually round to 2 decimal spots. That's what I recommend you do as well. All right, so if you want, you can take these two problems and try them on your own. You might want to just take a second here and pause the video and then go ahead and try to get your answers. I'm going to go ahead and start solving them right now. So if you want, go ahead and pause right now. All right, so in this case, 60 miles per hour. We've got to convert that into our physics units for speed, which is x meters per second. I know that 2.24 miles per hour is the same as 1 meter per second. So x times 2.24 is going to equal 60 times 1, and x is going to equal 26.79 meters per second. And then the next one, 3.5 meters is some x amount of centimeters. And I know that 1 meter is going to equal 100 centimeters. And I'm going to do x times 1 equals 3.5 times 100. And x is just going to equal 350 centimeters. All right. There are some other ways to convert. Although we ask you to do the proportion method, we understand that if you're competent in another way, that you can use it the other way. You just got to make sure that you are very good at this method. So this is another way that you might have been taught. So I'll go through it pretty quickly here. This is the dimensional analysis way. And in this way, whatever you're given, in this case 4 meters, that goes on the top left. Nothing goes on the bottom left. And then what you want to do is you want to say, I want to know how many feet are in 4 meters, just like we did earlier. So I'm going to put feet up here, and I'm going to put meters down here. And this is where you put your conversion factor. So I know that 1 meter is the same as 3.28 feet. And what we can realize is that the meters are going to cancel out, just like in a fraction. If you have 2 in the numerator and 2 in the denominator, they cancel out. So those will cancel. And then you just treat this almost like a fraction, where you would do 4 times 3.28 divided by 1. And you would get, just like we had before, 13.12, we are looking for feet. And we get the same answer as we did before. And if I did that for the problem on the bottom, whatever I'm given, 20 in this case pounds, goes in the numerator. Nothing goes down here. And I know that we want, we want kilograms. So I put kilograms up here. I'm going to put pounds down here. And that way the pounds and the pounds cancel out. And we know that 2.2 pounds is equal to 1 kilogram. And then we go ahead and we treat this just like a fraction. So if there are 2 numbers in the top or in the numerator of a fraction, we would do 20 times 1. And since the 2.2 is on the bottom, the denominator, we would divide. And you would do 20 times 1 divided by 2.2, and we would get 9.09 kilograms, just like we did before. That is about it. If you have any questions, let me know. Thank you very much.